The example give you how many forces? There are 1, 2, 3 forces, which are F1 equal 300 Newton, F2 450 Newton, and F3 is a 200 Newton. In the previous lecture, we want to find F1 if 1x direction plus F1y direction. F2, F2x in I direction plus F2y in J direction. And F3, F3x in I direction in J direction. Okay, my question is, why to find the final force, the resultant force, why I don't put Fr equal to F1 plus F2 plus F3? Because we want to find the resultant force, is it? So why I don't use F1 plus F2, F3? Let's say if F1 is 20 Newton, F2 is negative 20 Newton. Oh, sorry. F2 is 20 Newton. What do you think about this man? Is it move to the right or left or stay at the same place? Stay, because the force are same. Okay. So that's why if F1 this direction, what do you think? Is it left or right? You don't know it. Because F1 is not straight line. It have some angle. You don't know where is the direction, is it? So that's why you only can add or subtract the direction, the force, if they are in the same direction. So that's why the Fr here, you cannot use this one. Okay, the Fr, so F1 you need to separate in I and J direction. F2 you need to separate in I and J direction. And also F3 you need to separate to I and J direction. Then your Fr will be F1x plus F2x plus F3x in I direction. Okay, plus with F1 plus in J direction. Then you can get the Fr lah. So that's why you need to separate the F1 in I and J, F2 in I and J components, F3 in I and J components. Then you can find the Fr. Is it clear? Then the second question is you need to find the magnitude and angle for this. Magnitude angle. What is the formula to find the Fr magnitude? The I component, you need to Frx square plus with Fry square, and you need to square root. This is the general formula for the magnitude. So it means that whatever courses you take, either control, static, mathematics, and everything, this is the formula for the magnitude. Okay, so what is the final answer? $803.04 Newton lah. Okay, what is the angle? The angle and then the angle Fr angle equal to, this is the formula. Betul? Dapat apa?
Negatif 7.5.
7?
5.71.
So you can see that this is the resultant force. The resultant force. So if we draw the resultant force is at the negative direction of I. Is it correct? You look at this is X, which is I direction. This is Y in the J direction. Okay. If you look at here, the FR or the FRX, the value is negative. So it means that the FRX, is it right or left? So FRX in the left direction. Okay? Because the value of FRX, this is FRX, this is FRY. Okay, and then after that, the direction of FRY, is it positive or negative? Is it go up or down? Up. This is FRY. So, the combination of FRX and FRY, so this, if you look at the coordinate, this is the intersection, is it? So, this is your direction of FR. Okay, so it means that when you pull this one, F2, F1, and F3, so it means that this thing move to this direction. Is it correct? Because your FR show that the FRX go to the left, your FRY go to the up. So that's why the combination of left and up, so that's why it will move to this direction. Is it make sense? Yes. Okay, so it means that the angle here is 75.71 degree. So it means that I will zoom in this figure. This is X in I direction. This is Y in J direction. This is your FR. Okay. So, actually, the resultant force in this example, you can write in two different ways. Two different ways. The first type, you can write in vector form, which is, this is the vector form. FR equal to negative 198.2 in I direction plus 778.2 J. Because the vector will always tell you the direction. Or, you also can write the FR in what form? In magnitude and angle. So, the FR equal to, what's the answer again? 803.04 Newton with the angle of negative 75.71. Okay, so it means that in the exam paper, in the test, ngantuk sangat tu. Okay, in the test, the question can be find the FR. Either you, I can ask you in the exam, find the FR in the vector form. So, this is the answer. Or, I can ask you also, find the FR in magnitude and angle. So, this is the answer. So, it means that you can convert the force either in magnitude and angle or in the vector form. Okay, so actually, these information are same. Because if you use the formula of magnitude and angle, this is your answer lah. So if you use some formula, then you can convert this one to the vector form. So it means that this is can revert lah, revertible. You can change the forms. Okay. So now you know, right now you know how to convert from vector to magnitude and angle, is it? By using this formula. But do you know how to convert the magnitude? If you have magnitude angle, how you want to convert to the vector form? Not yet. We did not discuss about it yet. Is it correct? Okay, so we will discuss it later lah, not today. Okay. Although you are learn about 2D and 3D, kan? 2D vector and 3D vector, your objective still same. You want to find the FR in vector form. You want to find the FR in the magnitude and angle. Same thing. Although, because you already know that, you learn about vector 2D, you need to find the FR in vector, you need to find FR in magnitude and angle. Similar with the 3D, this is your objective. You want to find FR in vector, you want to find the FR in magnitude and angle. Same thing. Alright. So, I will give you an example. 3D vectors. Because you have X, Y, and Z. The first thing you need to highlight is X, you need to name as a I direction. Y, you need to name as a J direction. Z, you need to name as a K direction. Okay. So now, F1, what is the form of this information? Is it F1 in vector form? No, because there is no I, J, and K. F1 right now, what is the form of F1? What is the form? Because you learn two form, kan? Magnitude. Because this is the form of magnitude. Magnitude, kan? Can you find the angle? Yes, you can find the angle. What is the angle here? Can anyone calculate? You can use cos theta equal to 4 divided by, then the theta equal to 0. Berapa? 50? 53. 36. This one. Is it? Okay. Previously, I explained to you, you can convert the force either in vector form or in magnitude and angle. Is it correct? So, what do you think I want to do now? I want to convert this force in magnitude and angle to in a vector form. So, the F1 here, I can separate in which direction? How many direction? 3 directions, is it? In I direction, in J direction, and K direction. F1 in I direction, in J direction, and in K direction. Is it correct? Normally, I will name in I direction as F1 in the X axis. And then J, I name as a F1 in Y axis. This one should be this one, is it? So what we need to do now, we need to find what is the F1x value, what is the F1y value, and what is the F1z value. So we have F1. So should be here This is direction because we want starting from here to this point, is it? So we want to find the direction from the origin to F1. So from the origin to get here, the direction must go to where first? Sliding to y-axis first, is it? And then go up. Is it correct? Then it will move from origin to the final point. So what is the label here? Is it F1x, F1y, or F1z? F1y. Is it similar with the y direction? So if similar with the y direction, is it positive or negative? Positive. Okay? And then after that, it go up. When go up, what direction? Similar with the z direction, is it? So we name as a F1 Z. Is it positive or negative? Positive because same direction with the Z. So there's a positive. Is there any x direction involved? No. So it means that F1x equal to z, 0. Because not involve any x direction to get this force from origin to final point. So 0 in I direction. F1y is positive. Then you put positive F1y in j direction. F1z is positive. Then you put positive F1z in k direction. F1. Okay. Is it clear so far? Alright. So now your duty is you need to find F1y and F1z. Do you think you can get the answer? How? You use the theta and also the magnitude information kan? If we extract this one, it will be this triangle. Is it same thing? The theta here is 36.87. The magnitude here is 500 and the magnitude is 500. And then this line actually refer to F1y. This line actually refer to F1z. Can you find F1y and F1z? F1y, what you use? Cos theta equal to F1y divided by 500. Okay. So F1y actually 500 multiplied with the cos of 36.87. Then you get the F1y value. And the answer is, I believe should be, I use my head to calculate it. 400. So F1y is a 400 Newton. Don't forget to put Newton unit because force. So now, by using the same figure, can you find the F1z? What you can use? Sin theta equal to F1z divided by 500. So F1z, you get 500 sin 36.87 degree. You get 300 Newton. Okay, is it clear? So finally, F1 in vector form, this is the answer. The unit is Newton. conclusion, the F1 here is similar to 500 Newton, or in vector form, F1 also equal to 400 J plus with the 300 K. So it means that the F1 you can write in two ways, either in magnitude and angle, or you can write in the vector form. Okay. This is the second example for the 3D vector. It looks complicated, actually not, if you go to the basic again. Alright. I give you 1 minute to copy the question. I know my drawing is not good. Don't worry, because during the exam, the drawing will be okay. The figure will be okay. Don't worry about it. Okay. The F2 here, what is the form of F2? Magnitude and angle. Okay. The F2 form, which is in magnitude and angle. So what we need to find? F2 in a vector form. That's our target. Our target. We want to convert this F2 to a vector form. So, target, we want to find the F2 in vector form. Same thing, firstly, you need to divide F2 in I, J, and K direction. Is it correct? So, you will have F2x in I direction plus F2y in J direction and plus F2z in K direction. But now we don't know, is it positive or negative, something like that. We're not sure about it, is it? Okay, so now, in order from origin to F2, what is the direction from origin to F2? Previously, we can automatically draw something like this, it. From origin to F1. So now, what is the direction from origin to F2? The vector, we need to go to the basic vector shape in rectangular form. So from origin to F2, what is the rectangular direction? This one, and then, is it correct? Okay. From origin to this one and go there. In rectangular form, is it? Sorry, in triangle. Thank you for that. In triangle form. Okay. So, you look at the direction. We name as F, we name this one. Is it the direction follow the X, Y, or Z axis? This one. Is it parallel with the X, Y, and Z axis? Is it parallel? No parallel, is it? It's not parallel at all. So, if not parallel, so we name as F2 prime. We just name it as F2 prime. Because it's not parallel with the X, Y, or Z axis. Okay? This one. Is it parallel to X, Y, or Z? Which direction? It's, so we can name it F2Z because the direction is parallel, is it? However, F2Z is go up, but the direction go down. So is it positive or negative? Negative. Is it clear? Alright. Okay. But we already know this one. Okay. But in our figure, we can see F2X and F2Y yet or not? No, because we did not see any F2X and F2Y. So that's why this is okay. So the F2 prime, then we need to convert to F2X and F2Y. In order to get F2X, the vector to get F2X, is it correct? Which is if I can zoom in, this is F2 prime. I can zoom a little bit more bigger. This is Z, this is Y, and this is X. And this is your F2 prime. F2 prime. So in order to get from origin to F2 prime, the vector direction is from here and here. Are you sure? Is it correct? Okay. So, in order to get F2 prime, this one is X direction, is it? So, what is the label here? F2X. Okay. And then, is it parallel with this one? So, the label here is F2Y. F2X is positive or negative? Because similar with the X direction. F2Y positive or negative? So, positive F2Y. So, if I try to draw it again, based on the red vector, F2 equal to F2 prime here, plus with, minus with F2 Z in K direction. You look at F2 here, is combination of F2 prime plus with negative F2Z. Okay? So this one. But the F2 prime, we need to separate to X and Y or I and J direction. So when we try to investigate, the F2 prime here actually is a F2X in I direction plus with F2Y in J direction. So this information we replace to here. Okay, finally we get F2 actually equal to F2X in I direction and then plus F2Y in J direction and then minus in K direction. So now we already find the vector of the F2 in I, J and K direction. So it means that you need to do it step by step. You cannot, you need to, from the bigger, you need to make it detailed and smaller. Okay. So now we already separate the F2 in the I, J and K direction. Okay. So what our next task? We need to find the value kan? Value of F2X. We need to find the value of F2Y you need to find the value of F to Z. Okay. So if I can give you some information here, how many vectors we have? 1, 2 vectors. 2 information. The first information, if I can draw it like this, 45, 45. Okay. This one, F2, F2 prime. Kan? So this one is F2 prime. This one, F2 Z. The first vector. And then the value here is 800 Newton. The easiest way, you redraw again, you extract the information in a normal figure. What is the second information you have? This one, kan? You have this one, this line refer to this, which is F2x. This line we draw to go down, which is F2y. And this one, this line refer to F2 prime. Kan? What is the information that we not put here yet? 30 degree kan? Is it here? Is it 30 degree here? We'll say the 30 degree here. The 30 degree is at this location, is it? Okay. Alright. Our target, we want to find F2x, F2y, and F2z. Sorry, x. We want to find F2z, F2y, and F2z. Based on this figure, can you find F2y and F2x? Why? You need to know F2 prime value, is it? If you know the F2 prime value, you can calculate F2x and F2y. Okay. Based on this figure, can you calculate F2x? You can calculate F2x because you already have angle and magnitude value. Then you can calculate F2z. The F2z, what is the formula you can use? Cos or sine? Sine. You can use sine. Sine 45 equal to F2z divided by 100. And so the F2z equal to, what is the answer? 565. What is the unit? Newton. F2z. Okay. So now, we want to calculate F2x and F2y. What is the information that we need? F2 prime. Kan? So where do you think we can get F2 prime value? This one. Is it? So what is the formula to get F2 prime? Cos 45 equal to F2 prime divided by 800. So the F2 prime will be 800 cos 45. The answer is same lah. 565.69 Newton. So it means that the value here is 565.69 Newton. So you already know the magnitude, you already know the angle. Can you calculate F2y and F2x? Yeah. So F2x, you use sine or cos. F2x, cos. You just need to remember this one. If the angle here, the beside of the angle, cos. If the angle here, the opposite of the angle is sine. So that's why to calculate F2x, cos 30 equal to F2x divided by 565.69. Then you can get F2x, you get the answer. To calculate the F2y, because opposite of the angle, you use sine 30 equal to F2y divided by 565.69, and then the F2y, you calculate the answer. Okay. Wait a minute. Okay. Tunggu dulu. Is it F2x correct? Similar with your answer? Boleh dah duduk. Nama siapa?
Ilham.
Okay. Okay, so finally, your F2 in vector form is 489.902 in positive I direction, plus with F2y, which is 282.395 direction, and F2z equal to, mana F2z? This one kan? Minus with 565.69 in K direction. Don't forget to put the unit. What is the unit of the force? Newton, which is N.